What makes ecological flow modeling so hard to predict? Imagine trying to forecast how a river will behave years from now, knowing that countless factors are always changing. That's what makes ecological flow modeling so tricky. It's like trying to solve a puzzle with pieces that keep shifting shape and size. Rivers and streams are not simple systems. They are constantly moving, shaped by the land, vegetation, sediment, and the creatures living there. Every river has its own unique features, like different channel shapes and surrounding landscapes, which makes creating one-size-fits-all models nearly impossible. The way water flows affects and is affected by the plants and animals in the river. But these ecological responses depend on many things like the timing, strength, and duration of water flows. For example, a sudden burst of water during a rainy season can trigger different reactions in aquatic insects or algae than a steady flow over many months. These responses are often not straightforward. Sometimes they happen in nonlinear ways, meaning small changes in flow can lead to big effects, making predictions even harder. Data is another big challenge. Many rivers don't have enough long-term measurements of flow or ecological health. Without good data, models can't be properly calibrated or tested. Plus, the data that is available often has noise or errors, which adds uncertainty to predictions. This makes it difficult to trust the results or to know how accurate they really are. Models also have to consider many interacting factors. Changes in land use, climate shifts, or human activities like dam operations and water withdrawals can all influence flow and ecology in unexpected ways. These interactions can produce surprises that are hard to capture in a model. Vegetation along the riverbank adds another layer of complexity. Plants can slow down or speed up water flow, and their distribution can change over time, making it tough to predict how they will influence flow patterns. Scaling models from one river to another is also a challenge. What works for a small mountain stream might not work for a large river with different ecological communities and human impacts. This limits the usefulness of universal models. To improve predictions, scientists are now combining different approaches, like using machine learning and expert knowledge, to better handle the many variables and uncertainties involved. In practical terms, these models help us decide how much water to leave in a river to keep ecosystems healthy. They can help identify where flow has been altered and how to restore it. Sensitivity analyses can show which factors matter most, guiding better management. Combining ecological knowledge with real data helps us make smarter decisions for sustainable water use. But even with these advances, predicting how rivers will respond to changes remains a complex challenge because natural systems are so dynamic and interconnected.